All right, we are coming to the end of the day here at Data Day Seattle 2016, and always we're just getting a slew of incredible, engaging guests. Right now, we're going to be talking with Sanjay Joshi from Seattle.
Yeah,
and so it wasn't a far flight for you, right?
No.
And you are the CTO of Healthcare and Life Sciences at EMC, Emerging Technologies Division. Mm-hmm. Yeah, that's great. How have things been? I hear some exciting news, maybe.
Yeah. You guys are based in Austin. There's a small company in Austin that is going to be one with our small company based out of Boston and other places. Mm-hmm. I'm sure you've heard about Dell combining with EMC as one company.
Yeah.
The largest tech deal ever.
Wow.
I'm pretty excited. There's, for at least for our division, there's very minimal overlap. Mm-hmm. And our approach is specifically healthcare and life sciences, where Dell has done really well. They have an incredible reputation in the industry, in the healthcare and life sciences space. For me, it's the path of a single byte of information from compute all the way to deep archive.
Huh. Yeah, that is wild. Now, honestly, Dell is an Austin company, and I didn't make the association between Dell and healthcare, so this isn't a new move for Dell.
No, Dell acquired Perot Systems, which was a big name in healthcare for revenue cycle management, or RCM. Mm-hmm. Dell has invested heavily in the IoT industry in the past in healthcare.
Yeah.
They have a very, very good reputation. I was born in Bangalore, India. They're one of the largest employers in terms of R&D in Bangalore, India as well.
Yeah.
So is EMC, but they've been around for a little longer.
Yeah.
So they have, and in the genetic space, in the genomic space, Dell has contributed quite a bit, both on the high performance compute, the HPC side, as well as the individual contributions that Michael Dell has made. The Dell Hospital, the Children's Hospital in Austin as well, which is a very large imaging and genetic component.
Okay.
And we, the Emerging Tech Division, my division specifically, Isilon, we've been working in the life sciences space, the healthcare space, for quite a while. Our first customer was in the life sciences space about 10, 11 years ago. Mm-hmm. Our installed capacity, we have more than 350 customers purely in the life sciences space, core, pharmaceuticals, genetic research, things like that. EMC as a company has half of the hospitals in the U.S. as customers.
Oh.
So half of almost 6,000, so almost 3,000 customers in the healthcare space. So that it's very complementary in my view.
Yeah.
I'm pretty excited.
Okay. And that is extremely exciting. So now EMC and in healthcare, what is the application that?
Thank you. Yeah. Thank you for asking that. So there's a short and a long answer. Let me stick with the short answer.
Okay.
The short answer is, most healthcare is, when it reaches the patient, has to go through various levels of information systems. Mm-hmm. EMC actually provides the technology for the storage infrastructure for this information systems.
Okay.
I'll give you a quick example. When you go to the physician, in the last 2 or 3 years, you see them typing into a medical record system.
Right.
What that actually has to reside somewhere. This morning, the keynote speaker at Data Day Seattle was talking about data never being erased.
Yeah.
In the healthcare, life sciences vertical, this is very true, and I think there was a qualification that it may go away, but healthcare data never gets erased, on the average, no matter who you talk to. Mm-hmm. So that infrastructure is currently built for what I call the phenotype, or how the patient is behaving from an organ system perspective. Mm-hmm. As we look forward, that infrastructure also has to store information for the genotype, what's happening inside the cell.
Yeah.
And that infrastructure is literally 10, 100, 1,000 times bigger than the current infrastructure. So the question of scale becomes important, the question of cloud becomes important, the question of moving information, which is a huge issue in this space, becomes important, the question of what application layers you put on top becomes important.
Yeah.
So this is all critical issues for healthcare for the future.
Yeah, and this sounds like, like we're finally seeing the paradigm shift. We're finally getting out of the paper and these disparate systems and
silos.
yeah, exactly. And then I think what you're talking about, the storage of mass amounts of data, especially as we start getting more into genomics and more into I'm sure that we're on the very cusp of. When you're going in for a doctor, we know your blood type and we know what your genome says about you.
We're a little ways away, but I think a lot of the front guard of this information infrastructure, we have very large customers. I'll give you a very quick example. The Broad Institute in Boston has been doing this for literally 15, 20 years now at scale. The understanding, so there's both an excitement and a realism that comes in. The excitement is the more we understand about the body at the cellular level, implementing this new technology called precision medicine. And the tagline for precision medicine is the right drug for the right patient at the right time at scale. So the excitement is there, yet we are just starting to understand how the human body works.
Yeah.
And so, so there is a learning curve there, but I think the excitement is probably winning at this point.
Right. Yeah. Yeah. We don't care about walking. We just want to run.
Yes.
Yeah.
Yes.
And this is a little just an aside. I have to wonder if we're eventually going to see sort of the chemistry version of 3D printing. So basically the chemical printing movement, and when this customized medicine is just like...
Oh, it's funny you mentioned that. So this is public news as well. So Autodesk, the CAD company, has invested in a synthetic biology company to build chromosomes and to build cells from scratch.
Wow.
So talk about a software system, a CAD system that builds living things. I mean, this is a scary and exciting part as well.
Yeah.
But I take the more clearer road, to me at least, that there is a socially redeeming factor in terms of drug development, therapeutics, and so on, and early detection, which is a huge issue as well. So.
Yeah. And I was just finished talking with John Ackred about he's working with healthcare system to build a data system that reaches all the way to the hardware piece, and basically what we're going to be doing is allowing almost consumer grade blood monitoring.
This is fascinating. I came from the instrumentation world, so one of the most interesting devices I've seen is this little doohickey that looks like a triangle that you can point to any food that you're eating, and it'll take a spectral picture of that, and based on your allergy profile, it'll tell you if this food is okay in real time.
Wow.
So this is not even, you don't even have to go to the medical record system in the hospital. This is giving you instant feedback as to improving your life. I just put up a slide in my talk about the top 3 causes of death in the U.S. And the implication that changing diet can actually change the profile of disease is just dawning upon our citizenry and also people around the world.
Yeah.
Your grandmother was right. You are what you eat. And drink, I guess.
Well, and even there, like Ayurvedics,
medicine.
Where food is medicine.
It is. And maybe there was some empirical knowledge about using turmeric. I'm from India originally, and we use a lot of turmeric in our food. Yeah. And maybe it was a small grade antibiotic over a 30-year period that was more important.
Yeah, and and honestly, I use it too. I suffer from arthritis, and if I am experiencing joint swelling, I make a little paste with the turmeric, and
that's topical as well. So
I didn't know that.
Yeah, you can actually apply it on your.
That's interesting.
Anyway, so
that's amazing.
I digress.
No, but I think what the conclusion we're coming to is that data and data science is making a huge impact with healthcare, and I think that we are going to see just an impact in so many ways. Just day-to-day livelihood, preventing anaphylactic shock from someone who didn't know that contained peanuts or whatever.
Allergies are a huge thing. Let me give you a very quick example for clinical trials. Most clinical trials that we did till date were what were called prospective randomized. You're looking forward, you have an A to B comparison, and then you have to have a control, which is very hard to do. The clinical trials of the future, very data science-centric clinical trials of the future, I'll give you 4 different types. The first one is called N of 1, where every human being is special, and their data set is as important and very different from their neighbor's data set.
Yeah.
So that N of 1 patient-reported clinical trial is going to be very big in the future. The second one is called basket type of clinical trial. The basket type of clinical trial is where you have many drugs and many patients tested at once. Right now, we do only one drug for a large sample of patients. The third type is called cluster randomized trial. So clinical trials are very hard to do, they're very expensive. Cluster randomized trial is to take small clinical trials and then build the statistical power by combining many small trials together in a data world.
Okay.
And then presenting that to the FDA or the European Medicine Agency.
Yeah.
The final and the fourth type is what's called retrospective. You have done many clinical trials in the past that have either succeeded or failed, but that data resides today.
Yeah.
Can you reuse that data, make it retrospective, and then understand things better?
Yeah. Man, we could probably
Talk for hours.
talk for hours about this. But Sanjay, since we have to close the day, I know that the final talks are happening, and I personally look forward to seeing you at Data Day Health in Austin. What is that? 2017, I guess.
January 16th is what he told me.
Okay.
So.
Okay. I'll
See
be
you there.
there.
Okay. Thank you, Steve.
Yeah. Thank you.
Bye for now.
All right.